Hey everyone, hope you're doing fine today. My name is Simeon. I'm integration lead for Neon EVM. So today I will show you how you can deploy your Ethereum smart contracts on Neon EVM. And first I have a couple of questions. So I guess all of you are familiar with EVM and how EVM works, but is anyone familiar with Solana and how Solana works? No? No one? Okay. 2 people out of 50. Okay, that's still okay. 3 people. Okay, I can see some meme coin degens here. So maybe you traded some meme coins lately. So why I'm asking that is because Neon EVM is actually a smart contract in Solana, and we are basically combining the best of both worlds. Basically, we are one of the first parallelized EVMs because we share Solana underlying properties, and but also from developer perspective and builder perspective, you don't require any code changes. You can use your tools and your EVM stack to deploy smart contracts on Solana. And but also benefit from lower gas fees and also not global gas fee market, what we have on Ethereum, but just gas fee markets per dApp. So how does it work? As I mentioned to you, Neon EVM is a smart contract in Solana, and I want to share with you in a nutshell how does the Neon EVM architecture looks like. So we have Solana, and Neon EVM is actually a program in Solana that can understand and execute EVM bytecode inside Solana virtual machine. But this is one part of our architecture. If we only have the Neon EVM program, users and builders won't be able to use their, let's say, Hardhead, Foundry, MetaMask in order to interact with this smart contract. Why is that? Is because Solana has a completely different RPC and has a completely different transaction composition. So we also have our Neon proxy, which basically provides Ethereum-like RPC. It does some magic, I'm gonna explain later, unwraps the Ethereum-like transaction that the user submits, wraps it into a Solana transaction, and submits it to Neon EVM program. And then Neon EVM program just executes the bytecode and addresses this transaction. It looks pretty straightforward and easy, but as some of you don't know, maybe that Solana is completely different in terms of architecture than EVM. So the most distinctive part of that is that Solana smart contracts, they're called programs, they're stateless. So they don't have a state, and they use different accounts to store state. You can see here is a simple Solana program that you can see that we have the Solana program on the left-hand side, which only contains the Solana program bytecode, and the state is actually stored in another program-derived account that the program creates different accounts to store its data. So you can imagine Solana being like a very big file system where you have 2 different types of files. You have executable files, which are the programs, and you have also data files that are not executable. So programs can create their own data files, their own text files to store their state. And when it comes to Neon EVM is actually, again, a program, and it uses program-derived accounts to represent and to abstract away its own state. And for example, on the up, you can see that this is how an externally owned account in Neon EVM looks like. It's actually a data account, and inside it, we have all the metadata of an externally owned account. We have the Ether address, the nonce, the balance, and so on. And the same is with contracts. So the contract is again a program-derived account that contains all the properties of a contract along with the EVM bytecode. And also, the storage layout of the contract is stored in different accounts depending on the storage slot you are going to use. Basically, the first 64 slots are actually stored inside this the account that the program-derived account that is actually the bytecode stored, but every other slot is actually Neon EVM creates different chunks of program-derived accounts to store the storage layout. And this is how Neon EVM actually represents the whole EVM architecture and the whole EVM storage. And probably something interesting is you're gonna ask why Solana decided to go this way and why not having a stateful machine like Ethereum. It's because of optimization and because they want to have parallel execution. And in order to have parallel execution, you cannot have a global state. And what you should have is for each transaction, you should know exactly which account state you're going to be modifying, reading or writing from. Because on a node level, if you have this, I would say, this list of accounts you're going to interact and read and write from, on a node level, the node can easily order the transactions and can create and can execute some transactions parallelly and some transactions sequentially. So this is how a Solana transaction looks like. As you can see, we have account list. So account list is actually the list of accounts that are going to be read or read from for this transaction. And this is actually very important, as I mentioned, for leveraging parallel execution. If we go back, you can see that every contract, every let's say chunk of storage layout slots is account. Even externally owned account is account. Even Neon EVM is account. So we have this account list where actually this is what the proxy do, as I showed you here. So we submit Ethereum-like transaction. The proxy does a little simulation of this transaction in order to determine the account list of that is going to be used from this transaction, populates this account list, inserts the program index of Neon EVM, the data. As you can see, the data is all the metadata that Ethereum-like transaction needs, like nonce, gas price, gas limit, value, the transaction data, and so on, and actually submits this with the program index of Neon EVM. So Neon EVM understands of the nonces, of gas limit, and so on. You're gonna ask, okay, but in this account list, only Neon EVM address will always be there. Yeah. So in theory, we cannot leverage parallel execution. This is not true because Neon EVM is actually a program, and programs are stateless. So Solana node only cares about program-derived addresses and addresses that contain state and that contain data, not that are executable. So Neon EVM, even two transactions that have Neon EVM transactions, if they have different account lists, if we exclude the address of Neon EVM, they will be processed parallelly. So this is just a diagram showing how transactions are ordered. So the Neon proxy submits the transaction to the Solana RPC endpoint. As I mentioned to you, Solana is Neon EVM settlement layer. So you can think of Neon EVM is like a virtual machine inside the virtual machine. Like you have a Mac and you launch a Windows virtual machine on your Mac, or vice versa. You have a Windows machine and you launch a virtual machine for Mac on Windows. It's like just a composability layer and like a virtual EVM inside Solana. So we use Solana settlement layer, and it's something really more important is that you can natively call, and this is part of our roadmap to achieve general compatibility with Solana. So what you can do, some use cases, all those meme coins that are on Solana currently, you can basically deploy a Uniswap fork on Neon EVM, create a ERC20 wrapped SPL token. Basically, you can wrap the meme coin that is on Solana, you can wrap it in an ERC20 interface and create a pool or do anything. So you can access Solana liquidity in that case. And this is done natively because Neon EVM lives inside Solana. You don't need to do like a bridge transaction. You just need to transfer your Solana, your SPL token from your Solana account to your Neon EVM account. And some incoming features, actually this is already live. So we are supporting, and the bridge is supporting us, which means that you can transfer tokens from 16 or more EVMs to Neon EVM. And also you can see we have Neon Pass. Neon Pass is our native bridge that is used to transfer tokens from Solana to Neon EVM. But why I say bridge, and bridge is in quotes, is because we are not really bridging from one chain to the other. We are just doing a native transfer from one account inside Solana to Neon EVM account that represents your MetaMask address, because we know that Solana addresses and Solana addresses are different than EVM addresses. So Neon EVM supports EVM addresses, so you need just to transfer your SPL tokens to Neon EVM account that represents your Ethereum and MetaMask address. Another really interesting feature that is gonna go out in the next month or so is multi-token gas payments. This feature is actually really interesting. You'll be able to pay for gas not only in Neon, because Neon is the main gas token. You will be able to pay gas in different currencies like Solana, USDC, and so on. And how this will happen? You just have to connect through different RPC. So everything is abstracted away. Neon EVM will have RPC, for example, for USDC payment, RPC for Solana payment, and there will be possibility through the DAO to launch new gas payment tokens. For example, if the community decides that they want dog with hat and they want to pay the transaction fees with dog with hat, okay, so if the DAO agrees, we can add dog with hat as a gas payment token. Composability. So as I mentioned with you, we already have our first case of composability and interoperability with Solana, which is which I'm gonna show after that. And you can, in theory, you can natively call any Solana program within Neon EVM, within your Solidity smart contract. We aim to achieve general interoperability. What that means is that, for example, you can launch, you can interact with Orca, with Radium Exchange, with any other protocol on Solana from Neon EVM, from your Solidity smart contracts. And this is a very good use case, for example, for DEX aggregators, because you can aggregate from 2 chains and you can execute on 2 chains just using one source of code. You can have a Solidity contract that can execute on both chains. You can do, you can mint NFTs, and basically you can read any arbitrary data from Solana. For example, you can get some account data from Solana and distribute rewards on Neon EVM or vice versa. So the possibilities are endless. So we are releasing this or next week this feature on DevNet, and my team is going to test and provide a lot of feedback and also tutorials to developers how they can use this general interoperability. And I guess in around month or 2, I think 2 months, because we need to undergo some security audits, we're gonna have this feature on mainnet. Yeah, you can follow us. I will leave this after the lecture, but let me show you something else. I want to show you how you can deploy, and basically how does one ERC20 looks like that is underlyingly calling SPL token. Hope you can see this, yeah. Okay, so as you can see, this is a contract that is actually having an ERC20 interface, and you can see that underlyingly we are calling something like Metaplex. Here we are calling SPL token. And what is that? This is actually the program on Solana that is like a centralized registry for all tokens, SPL token, and Metaplex is centralized registry for token metadata. Interestingly, Solana decided to have everything in one centralized place, not like EVM concept of ERC20s, where different tokens are different contracts by themselves. Some people think that this is good, some people think that's not, but it is what it is. So how does this work? Is we have created some precompiles, and those 2 precompiled contracts, they interact natively with SPL token and with Metaplex token. So underlyingly, you're calling the real token. You can see that even for approve and transfer, we are calling underlyingly SPL tokens. And even for say transfer, we are calling the SPL token on Solana. So you can go and have a look in. We have created. I think you can see this. No. I think it's not here. Maybe. Neon. So in our GitHub, you can Neon Labs GitHub, yeah. You can come and search tutorials. And we have a whole bunch of tutorials: how to deploy an ERC20, how to deploy an ERC721, how to integrate with Chainlink, how to integrate with PIS. Also, we have a Foundry example here. You can check it, and you can play with it. When it comes to RPCs, you can use Chainlist. And if you click DevNet, you can see that we have 2 RPCs. And also for mainnet, we also have, in practice there are two, but we also have dRPC, and dRPC is actually just the same RPC as Everstake. Yeah. So you can get this, and basically, as you can see, this project, it's a simple hardhat project. So we have, you just need to add your chain configuration here, and everything should work out of the box. We appreciate if you give any feedback of our documentation. We also have our documentation here, and I think it's, yeah. We also have our documentation, so you have also all the information should be here. How to integrate and how to use MetaMask, how to use, we have also Neon Faucet, which can give you 100 Neon if you ask it, for DevNet, of course. And yeah, so I have already deployed one token, and I just want to show you something interesting. So let's just send from account 2 to account 3 this ETH Seoul token. Send 100 tokens, yeah. And what I want to show you is that this is not, and also in our tutorials, we always show how you can deploy an ERC20 that is underlyingly an SPL token. So in theory, you can even launch your own meme token if you don't have any knowledge about Solana. This is actually the purpose of Neon EVM, to abstract away all Solana complexity, because I have also come from background, EVM background. Okay, you can see this is our Explorer. And interestingly, each Neon transaction maps to one or more Solana transactions. Why more? Is because sometimes Solana is also restricted in terms of memory per transaction. And as we know, Ethereum and EVM transactions are only limited by the gas limit of the block, 30 million. So sometimes EVM transactions is too big, so we need to, it's called iterative mode of transaction. We need to perform a couple of transactions that constitute in one EVM transaction. But here, luckily, it's only one Solana transaction. If we click here, you can see initially that we have transferred in Neon EVM 100 Ethereum Soul transactions, Soul tokens, sorry. And you can see this is the Solana Explorer and the underlying Solana transaction. And you can see that here again, we have a transfer. And this is actually our token on Solana. And you can see that we have 1,000 token supply. So you can do this, you can deploy that, and probably in the next couple of months after we launch general interoperability, there will be even much more use cases for NFTs and for anything that can come to your mind. So I would suggest to go ahead to check our docs. Also follow us and join our Discord. We have a developer channel there, so whatever questions, whatever problems you might have, or even any feedback. We accept any feedback regarding our documentation is welcome. Also, I want to talk about the bounty. We have a bounty here, and we welcome any creative ideas that can leverage either parallel execution or low transaction fees, or even if you decide to create, let's say, a native product on Neon, we can also potentially invest in such kind of projects. For example, projects like NFT marketplaces are something that is really good, and we currently don't have, I think, on Neon. You can go on our website and check our ecosystem page. So if you write Neon EVM, and if you click ecosystem, I think it's down. Yeah, here, explore ecosystem, and you can check actually what are the dApps. So any dApps are welcome. We are going to also manage and assess creativity and vision of the project. So whatever idea you have, even if it's really crazy idea, even if you want to do a meme token, just don't worry about that. And yeah, I think that's pretty much it. Please join our Discord and engage with the developer community. We are always there and try to support. Yesterday we had the DevNet maintenance. I tried it today. Everything should be working. But even if at some point something is not working, don't worry, just message me or message in the developer channel. So because on different hackathons, we used to even choose winners that didn't manage to deploy some part on Neon, but they deployed on, for example, on Sepolia, but their idea was too good. So we can give you another chance to deploy. So this is not a big issue. I think that's pretty much it. Anyone have any questions? No? Okay then. Thank you very much, everyone. It was a pleasure.